Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends, to your friends. That's the only way you can keep me going, refreshed and inspired. And if my videos and if your videos are important to your studies, please don't forget to subscribe. Determine the maximum value of the following: reaction at A, reaction at B, shear at C, moment at C, and the absolute maximum moment. So here is the given figure. The span, simple span is 40 meters, and 10 plus 14, 24 plus 8, 32. So there will be no incoming load when we position the loads to over the support sample. So our criterion for reaction would only be WH over L minus P1, then plus P1H, sorry, WH over L minus P1 only. So when that, assume that the loads are moving from right to left, so when the 30 kilonewton load is over A, there will be no minus P1, so initially it starts with positive sign. So we then move the 75 kilonewton load over C so that the 30 kilonewton load will be of span. This is our P1. H is 10, and W would be 100 plus 100 plus 75. That would be 275. So delta VR equals 275 times L times H 10 over L 40 and minus P1 30. So the sign is still positive. Next, we move this 100 kilonewton load over A. So our W is 100 plus 100 and our P1 is 75. So delta VR is 200 times 14 over 40 minus P1 75, and that becomes negative. Then for preceding position of loads, that is the 75 kilonewton load over A gives maximum reaction at A. So this should be the positioning of the loads to give maximum reaction at A. So to solve for reaction at A, we sum up moments about B equals 0. So RA max times 40 equals 75 times 40 plus 100 times 26, because 40 minus 14 is 26. Then 26 minus 8 is 18, so plus 100 times 18. So RA max equals 185 kilonewtons. For P, for maximum reaction at B, so the loads are now moving from left to right. So when the 100 kilonewton load is over B, this 100 here, initially there will be no minus P1, so it starts with positive sign. So when the next 100 kilonewton load is positioned over B, so that means our P1 is 100, our W would be 100 plus 75 plus 30, that's 205, and H is 8. So delta VR equals 205 times 8 over 40 minus 100. And the sign is negative. Therefore, the preceding position of loads, that is this first 100 kilonewton load over B, satisfies the criterion. So this should be the positioning of the loads to cause maximum reaction at B. So we sum up moments about A equals 0. This is 8. RB max times 40 equals 100 times 40 plus 100 times 32. 32 minus 24 is 18, so plus 75 times 18, and plus 30 times 8. So RB max equals 219.75 kilonewtons. This is also the absolute maximum shear if it is asked in this problem. Next, for V sub C, so we assume that the loads are moving from right to left. So because 10 plus 14 is 24 plus 8 is 32 greater than 28, there will be an incoming load. So our criterion would be WH over L minus P1 plus P1H over L, then plus PD over L. So WH over L minus P1 plus P1H over L plus PD over L. So when the 30 kilonewton load is over C, the sign is positive because this 100 is not yet included, then there will be no minus P1 yet. So we proceed with the 75 kilonewton load over C. Our H is 10. Our W would be this will be when the 75 kilonewton load is over C, this will be an incoming load. So W would only be 100 plus 75 plus 30 to 205. This is P, incoming load, which enters the span by, because this is 22, so 6 meters. 14 plus 8 is 22, so 6 meters. And W is 175, 205. So our delta B is WH over L minus P1B over L plus PD over L if P1 will be off span in this formula and there is an incoming load. So here, because P1 will fall on the beam because H is 10, so delta V is 205 times 10 over 40, then minus 30 plus 30 times 10 over 40, this term here, and there is an incoming load of 100 times D, which is 6 over 40. So the sign is positive, still positive. Next, we move 100 kilonewton over C. Our P1 is, there will be no P1H over L, there will be no incoming load, and we will use this formula because the 75 kilonewton load, which is supposedly our P1, will fall on the ground because the distance is 14 and this is only 12. So delta V equals 200, 100 plus 100, when this 100 kilonewton load is moved over C, times 14 over 40, then minus P1, which is 75 times B, which is 28 over 40, then this is 0, there will be no more incoming load. The sign is still positive. Finally, when the last 100 kilonewton load is positioned over C, so W would be 200, P1 is 100. So WH is 8 over L 40 minus 100. That's the criterion. Anymore? Then plus 100 times this term here, 100 times H 8 over 40 the sign is negative. So that means preceding position of loads, that is this 100 here over C, gives maximum shear at C. So only two loads on the span gives maximum shear at C, and the maximum shear at C is the reaction at A if you draw the free body diagram. So RA equals V sub C. So RA times 40, summation moment about B equals 0, equals 100 times 28 plus 100 times 20. Is 100 there times 20. So R sub A is 120 kilonewtons. Therefore, that's also the maximum shear at C. Next, we proceed to moment at C. So for moment at center, criterion would be W over L minus W1 over A. Delta M equals 0. Where L is 40 and A is half of 40, 20. Means W1 over for a moment at C. So W1 over A 12 equals 0. So delta M equals, this is when the 30 kilonewton load is just to the left of C, so that this is part of the W1. So take note that 10 plus 14 is 24 plus 8 is 32. So this 100 kilonewton load is still out of span. So W would be this 3 here. 175 plus 30, 205 over 40, then minus 30 over 12. And that is equal to positive when the 30 kilonewton load is over C, just to the left. When the 75 kilonewton load is over C, just to the right, the same value, the sign would still be positive, and W this time would be plus 100, so that would be 305 over 40 minus 30 over 12, so that's still positive. But if the 75 kilonewton load is just to the left, then W1 would be 30 plus 75, and W would be 305. So delta M is 305 over 40 minus 105 over 12, and that is now negative. So that means the preceding load, the 75 kilonewton load over C just to the right, gives maximum moment at C. So this would be the position of loads that would give maximum moment at C. So that's RA, that's R sub B. Although the next load would be 100 heavier, but there will only be two loads on the span if that's the case, although it will satisfy. So to solve for moment at C, we solve for RA first. We sum up moments about B. So RA times 40 equals 30 times 38. That's 38. 10 plus 28 plus 75 times 28 plus 100 times 14, because 28 minus 14 is 14. Then plus 100 times, this is 6. So R sub A is 131 kilonewton. So the maximum moment at C is RA times 12 minus 30 times 10. That's the first possible value. So MC1 equals 1272 kilonewton meter. We then proceed with 100 kilonewton just to the right of C. So that would be W200 because these two will be obspan. That's 12 only. So the initial value is positive. Then when the 100 kilonewton load is positioned just to the left of C, this is part of W1. So delta M equals 200 time over 40 minus 100 over 12. This is when the 100 kilonewton load is just to the right of C, so there will be no W1. So that's why it begins with positive. When the 100 kilonewton load is just to the left of C, so delta M is 200 over 40 minus 100 over 12. So that would be negative. Therefore, the preceding position, the 100 kilonewton load just to the right of C gives maximum moment at C. Or simply, the 100 kilonewton load, this 100 here, over C gives maximum moment at C. Okay, let's position it and let's solve for RA by this position. So summation moment B equals 0, RA times 40. RA is 120 kilonewtons from the preceding position of the loads, or RA times 40 equals 100 times 28 plus 100 times 20. It will give us 120. So the maximum moment at C is 120 times 12 MC2, and it is equal to 1440 kilonewton meter. Because this is greater than the first, therefore MC max is 1440 kilonewton meter. So that's the answer. Next is moment at center. Criterion: W over 40 minus W1 over 20, half of 40 equals 0, or W over 2 minus W1. So since the 100 kilonewton load gives maximum moment at C, so the resultant and this 100 kilonewton load must be equidistant from the center to give maximum moment at C. So let's put the 100 kilonewton load over C. So W is 275, and 275 would be when all these three loads, this center load is over, this center load is just to the left of the center, so this 30 kilonewton load will be off span. That's great because the distance between 30 and this 100 is 24, and half of the span is only 20, so this means this is out of span. So W would be 275. Take note, this 100 kilonewton load is just to the left of C, so this is part, these two would be part of W, 175 plus 100, and the total W is 100 plus 100 plus 75. They remain on the span, so 275 over 2 minus 75 plus 100 is negative. So that means this 100 kilonewton load just to the preceding position, just to the right of the center line, gives maximum moment at the center, or simply this 100 kilonewton load over the center of the beam gives maximum moment at the center. So that's it. So because we want the absolute maximum moment. So this should be the resultant, the distance of the resultant, and this 100 kilonewton load would be E. Then by Varignon's theorem, 275 times E equals 75 times 14 minus 100 times 8 equals 75 times 14 minus 100 times 8. So E equals 10 over 11 meters. So we then, E is 10 over 11, we then position the resultant and the 100 kilonewton load such that their center is also the center line of the beam by principle as shown. So R is 275, distance is E, so that means the distance of this center 100 kilonewton load from B is 20 minus E over 2. 20 minus E over 2, E over 2 is 10 over 22, is equal to 215 over 11. So this distance is also 215 over 11. So again, 20 minus 10 divided by 22 is 215 over 11. So to solve for the maximum moment, the absolute maximum moment, which occurs over this, under this 100 kilonewton load, is RB times 215 over 11 minus 100 times 8. So let's solve for RB first. Summation moment A equals 0. R sub B times 40 equals 275 times 215 over 11. So R sub B is 134.375 kilonewtons. So finally, M absolute max is RB 134.375 times 215 over 11 minus 100 times 8. So M absolute max equals 1826.42 kilonewton meter. So that's it for this problem.